Okay, I'm going to finish up this review today, and the first problem I'm going to do is number 6. Actually, it's the 6th problem, but what we have here is the cosine sum, so this is equal to the cosine of 120 times the cosine of 45 minus the sine of 120 times the sine of 45. Those are pretty easy angles to get. Sine 45 and cosine 45 is that triangle here, but 120 is this triangle that we want. So we want this 60-degree angle right here. And then this is 120. So this is 1, 2, root 3, and this is a negative 1. So cosine of 120 is negative 1/2. Cosine 45 is 1 over root 2. And this is minus sine of 120, which is square root of 3 over 2. Times the sine of 45, which is positive 1 over root 2. So we simplify this and get negative 1 minus root 3 over 2 root 2. You can rationalize that denominator if you'd like, but that's okay. Number 7 is the sine of 105. Well, 105 equals 60 plus 45. So we really have just two pretty simple triangles here. This is equal to the sine of 60 plus 45. So this is equal to the sine of 60 times the cosine of 45 plus the sine of 45 times the cosine of 60. So we have some pretty simple triangles here. If you can't remember the 60-degree triangle, I'll draw one here. So here's your 60-degree triangle. This is my 60-degree angle. So this is 1, 2, square root of 3. The sine of 60 then is square root of 3 over 2. Cosine 45 is 1 over root 2 plus sine of 45 is 1 over root 2, and the cosine of 60 is 1/2. So we get square root of 3 plus 1 over 2 root 2. Okay, moving on to number 8. Now, problem number 8 says find the exact value of the sine of u plus v, where sine of u is this, and cosine of v is this. So those are two different angles, both of them in the second quadrant. So I'm going to draw u here. So here's my u, and based on the fact that the sine is 8 over 17, I have 17, that's an 8, 15, 17 triangle, and this is my angle u. Well, actually, this is my angle u. But this will be my reference angle, negative 15 for my x value there. Now, the V angle is this, so I again have that in the second quadrant. This is my right triangle. And the cosine of V, which is actually this angle here, is negative 60 over 61. And that's a 11, 60, 61 triangle, I think. So now we have the sine of u plus v that we have to find, which is this right here. This is equal to the sine of u, okay, times the cosine of v. These are my inputs here. Minus, or no, plus, because it's the same, sine of v times the cosine of u. And so this is equal to the sine of u, which is 8 over 17, times the cosine of v, which is negative 60 over 61, plus the sine of v, which is 11 over 60, and the cosine of u, which is negative 15 over 17. 11 over 61 for this here, actually. So the cosine of u, again, is negative 15 over 17. Now I'm just going to check the arithmetic on that for problem number 8, and I think I have the answer key down here. And it is negative 645 over 1037. So negative 635 over 1037 equals negative 635 over 1037. That's an easily done problem with the calculator. But again, these are my outputs. Output, 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 output. And these are my inputs. Input, 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 input. Moving on to problem number 9. Use an inverse function. to write theta as a function of x. So I'm going to use the cosine function. So I know that the cosine of the angle is x over 3. So I know that theta is equal to the inverse cosine of x over 3, and that's theta as a function of x. There you go. Find the exact value of the arctangent of 11 over 60, and that's with the triangle here. The output of this is in the angle, so this is equal, this piece here, I'm going to make theta, and I'm going to put theta right here. So then the arctangent of 11 over 60 means I have opposite over adjacent. This is an 11, 60, 61 triangle, so my hypotenuse is 61. So really, I want to find the, I want to find the cosine, let me exit that, the cosine of theta, which in this case is 60 over 61. Finish with that problem. Problem number 11 says a plane is 52 miles west and 36 miles north of the airport. So I have to draw where my plane is. So it's 52 this way and 36 this way, and my triangle is here. I need to draw another compass right here that tells me the pilot wants to fly directly back to the airport. I need this bearing right here. Okay, so that's the theta that I'm looking for, and to figure that out, what I need is really this angle here. If I find this angle, oops, let me draw that in black. If I find this angle here, I can find the rest of it. So that angle there I'll call theta, and I'm going to use the tangent function. So I'm going to use the tangent of theta is equal to 52 over 36, and theta is equal to the inverse tangent of 52 over 36, and so theta is roughly 55 degrees. And so if theta is 55, I'm going to take 180, take away 55, that gives me 125 degrees. Now for these problems, remember that all airplanes need to just go directly clockwise north. So my answer then is 125 degrees. Let me just check that, go down to problem number 11 and the answers here. Pretty sure I have it right. Oops, I don't have 11 for the answers. So you got to trust me on this one. If I make a mistake, please let me know. Problem number 12, it says verify the identity. Then it looks like I'm going to change everything to sine and cosine. So to try to get my sine value here on the right. So I have cosine of theta, that's already in terms of cosine, times sine over cosine, sine theta over cosine theta, minus 1 over cosine theta, parentheses, and this is all over 1 minus 1 over sine theta. Now this is going to be, this function will be distributed here. So the cosines cancel out on the over here, so I get 1 over there, and so I get sine theta minus 1 there. And this is divided by 1 minus 1 over sine theta. Now, I've got to work with this denominator here. So this is going to be sine theta minus 1 over sine theta minus 1 over sine theta. Kind of running out of room there. But you can see if you multiply by the reciprocal of this, you're going to get, let me grab a red, you're going to get sine theta. So that one wasn't too bad. That's what we need there. Problem number 13 is a graph. I need to see this as equal to the tangent of 1/4 x. This value here is b, and the period of the tangent function is pi. So pi over 1/4 is equal to 4 pi, which is my period of this function. Tangent function does the Hilbert twist at the origin. This one does the same thing, only my period is 4 pi, so I'm going to go 2 pi on the right, and I'm going to do 2 pi on the left, and this is actually negative 2 pi, and halfway is pi, so it's going to be 1 here, and halfway here is negative pi, and it'll be 1 here. And tangent functions are asymptotic, so I twist here and here. And there's 1 period of that tangent function. Tangent of 1/4 x. Okay, remember that the period of the tangent function is pi, and so pi over b, which is 1/4 in this case, is then 4 pi. So I spread it out here and here. Okay, moving on to the last graph, which is 1 minus 3 times 2 times the sine of x plus pi over 4. There's a couple things going on here, well, more than a couple. So first of all, let's figure out our period of this function and our amplitude and shifts and those kinds of things. So this thing has a period, this graph has a period of pi. How did I get that? Well, this here is b. So my period is then, my period is 2 pi over 2, which in this case is equal to pi. So that tells me that my period is pi. Now, this graph is then shifted to the left, pi over 4, indicated by this function here, or this number here, plus pi over 4, which indicates that this graph is shifted to the left pi over 4. That tells me where I'm going to start my table right there. Now, this function is a couple things going on. It's going to be a reflection and have an amplitude of 3. Also, this function is going to be up 1. So there's a lot going on here, but we can figure this sort of thing out with a table. And we have to recognize that this function is the sine function. And the sine function's pattern, we see, the sine function's pattern is here. See, 1, 2, 3, boom. This thing's going to have the same type of pattern as the sine function does. We can see this pattern here with the sine function. We can see that it hits here, here, and here on the axis. So where are we going to start? Well, I'm going to start with the table for this one. And I'm going to say my x here and my y here. And I'm going to start at negative pi over 4. Now I'm going to end this period 1 pi later. So I'm going to add pi here. And so this period is going to end at negative 1/4 plus pi, which is going to be 3/4 pi. So I'll put 3/4 pi here. That'll be the last value I come up with. In one period anyway, the period here. So what are these other values? All right, so let's figure that out. Well, oops, let me move this up a little bit here. Can I erase that? Oops. All right, so here's the middle, or here's the start, here's the middle, here's the end, which is 3 pi over 4. Okay, so negative 1/4 pi, what's this output right here? That's what we want. Well, this graph is going to be shifted up 1. So instead of starting at 0, it's going to be lifted up 1. The sine function starts at the axis, so we're going to be okay just by putting our starting point. So we're going to go left pi over 4, which we indicated here, and we're going to go up 1. So really my starting point is going to be 1. Okay, so where were we? I had to stop the recording there for a second. So negative pi over 4 is an output of 1. And in the middle of this period is going to be pi over 2. and in between negative pi over 4 and pi over 2, oops, I'm sorry, the middle is pi over 4, whoops, and here is pi over 2, that's where pi over 2 was, and right here is 0. So at pi over 4, this graph is 1 again, and at 3 pi over 4, this graph is 1 again. Now at 0, the graph is negative 2 because of the amplitude of 3. And because a is less than 0, it's forcing the graph down. So then I have go back up to 1 again, and then here I'm going to go up to 4. So let's get this thing on a coordinate plane now. So we have a graph that looks like this, and then we have negative pi over 4 here, and pi over 4 here, and pi over 4, pi over 2, 3/4 pi, pi, and pi is here. 1, 2, 3, 4 would give me 2 pi. Negative pi over 4, I'm going to use 1, 2, I have to go all the way up to 4, so I'm going to go 3, 4, and I'm going to go 1, 2, 3, 4 on the negative side. And here we go. Negative pi over 4 is 0. Oops, my fault. Back it up. Negative pi over 4 is a 1. 0 is going to be negative 2. Pi over 4 is back up to 1. And pi over 2, which is right here, is up to 4. Here. Then 3 pi over 4, which is right here, is back to 1. Now, this is one period of the function. It goes up or down, forced down because of the negative, and then back down. Now there's the pattern of the sine function, and you can see it right here at pi. It's going to go down to 1 again. At 5 pi over 4, it's going to go up to 1. This is back down to negative 2. And one more pi, it's going to go up to 4 and back down to 1. And I'm going to smooth that curve out. There's my second period. So that's that graph, and look that over and do your best with that. Number 15 is a tangent to theta formula, so we have to look that up. And tangent to theta is equal to 2 tangent theta over 1 minus tangent squared theta, and in this case it's going to be 2 times 2/3, opposite over adjacent, 1 minus 2/3 squared. We need to simplify this. This is 4/3 over 1 minus 4/9, and this is equal to, I'm going to go right here, 4/3 over, this is 9/9 over 5/9. This is equal to 4/3 times 9/5. I got a reduction here, and I end up with 12/5. There you go. So applying the formula. Next problem is use a quadratic formula to solve the given equation. We're going to skip that part and then use a graphing calculator. So we're just going to use a graphing calculator for this. Okay, so now the last problem that we're going to do on this review is this problem. Well, we're not going to use a quadratic formula, we're just going to use the Inspire. And when you do this into the Inspire, don't forget that it has to look like this. 18 times the cosine of x, but then you're going to put the squared right there. Minus 13 times the cosine of x plus 2 equals 0. Now when you find your zeros, you're going to get them as 1.05, 1.35, 4.94, and 5.24. So check that and practice getting those zeros on your Inspire by pressing. It's going to be, make sure a couple of things happen. Make sure you have your zoom trig on. Make sure you're in radians. Make sure that you do a menu 6, and then analyze the graph. And when you analyze the graph, you're going to find those zeros, and you have to do it 4 times. Okay? Have a nice day. Watch this video and study for your test. Dang it.